Hi, welcome back. Today we're going to be talking about solving word problems that involve discrete objects. Throughout this course, we're going to be seeing a number of word problems that involve collections of objects. For example, here's a question. Are any natural numbers both square numbers and prime numbers? This video is about developing a strategy for solving such problems. And by the end of this video, we'll answer this question. Let's get started. Here are the steps you should take whenever you want to solve a word problem involving collections of objects. First, identify the given information. Then, develop a model for the problem. Then, do the math. And last, answer the question. So what do we mean by those things? Word problems necessarily mean that the problem is written in English. And every language out there is imprecise. So to be able to answer these questions, it's important that we can parse the English words into mathematical ideas and concepts. So we're given a problem, and we want to identify the given information. What exactly are the collections of objects that are involved in the word problem? It's best to write those down in words. Also identify what are we being asked to do, and think about what an answer to your question will look like in the end. Once that's out of the way, create a variable for each of the sets and define them carefully. Then translate the interactions between the sets into mathematical ideas such as set operations. Now that everything is precise, go ahead and do the math. Perform those set operations. You may have to use some of your mathematical knowledge, some of the things you know about integers and ways in which the real world works, and put them all together to figure out what the mathematical answer to your question is. And finally, once you have that mathematical information, you need to go back to what the original question is and make sure you answer it carefully. You need to interpret the mathematical results as an answer to the question, making sure to use complete sentences. Let's put this into practice in the word problem that we started with. Are any natural numbers both square numbers and prime numbers? So let's identify the given information. This question involves two sets. We have natural numbers that are square numbers and natural numbers that are prime numbers. And so let's write those two down and recognize that the question is asking us to determine if any number is in both of those two sets. Okay, next step. We need to develop a model for the problem. We had written down two sets. Now let's give them variables and define them precisely. Our set of natural numbers that are square numbers we'll call A. If we want to write that in set builder notation, we would say it's the set of natural numbers little n, such that n is equal to k squared for some natural number k. If we want to make the set B precise, we can say it's the set of natural numbers n, where n is prime. And we want to know if any number is in both sets. Now, throughout this video and the other videos in this learning objective, we're going to focus on some keywords. In this case, we have the keyword AND. When we have a collection of objects that's satisfying two conditions, condition 1 and condition 2, the set operation you should think about is intersection. It's natural to bring up the idea of intersection because we can think of condition 1 as restricting the universe of possibilities, and condition 2 also restricting the possibilities. So if we're applying both of the conditions together, both of them are restricting the possibilities further, just like how an intersection is the restriction of elements that are in A and in B. So if we head back to our question about square numbers and prime numbers, what we want to know is, are there any elements in A intersect B? Is that set the empty set, or does it have at least one element in it? This question, is A intersect B equal to the empty set, is the same as asking, are A and B disjoint as sets? Now that we've fully taken our question and put it into mathematical language, now we have to do the math. An element being in set A means that it's equal to k squared for some natural number k. N being in B means that n is at least 1, and the only divisors of n are 1 and n. So in order to see if these sets have anything in common, we should think about what the divisors are of a number in A. If a number in A looks like k squared, maybe we don't know all the divisors of n, but we do know that 1 divides k squared, k divides k squared, and k squared divides k squared, which means if n is bigger than 1, then n has at least 3 divisors. But the rule for if a number is in B is that if n is bigger than 1, then n has exactly 2 divisors. So no number bigger than 1 can be in both sets. Let's check out numbers less than 1. When n is equal to 0 and n is equal to 1, 0 is in A and 1 is in A, but neither 0 nor 1 is a prime number. And so the intersection of these two sets is the empty set. Or in other words, A and B are disjoint. So now we've done the math, and we know that there are no elements in both of those two sets. So we then translate that into English and we say, the answer to the question, are any natural numbers both square numbers and prime numbers, is no. No natural numbers are both square numbers and prime numbers. That's it for now. See you in the next video.